Okay, question 11. So he says, guys, sketch this function. Now what I'm going to do is I'm going to sketch, because this is a reciprocal function. So what I'm going to do is I'm going to sketch x squared minus 2x minus 3. I'll sketch the quadratic first, and then I'll sketch the reciprocal function. So we're going to sketch this one, x squared minus 2x minus 3. Now this guy, this is a quadratic that hopefully we can all sketch. Minus 3 times x plus 2 plus 1, sorry, are the factors, which means there's a an x-intercept at 3 and an x-intercept at -1. There's also a y-intercept when x is 0 at -3. Let's put it here. And there's a minimum. The min is at, you can do minus b over 2a, which is 2 over 2, which is 1, or just recognize it's halfway between. So this guy is -1 and this guy's 3. The x coordinate of the minimum is halfway between -1 and 3, which is 1. Then to find the y coordinate, we sub 1 in here. 1 squared minus 2 minus 3 is -4. Okay, drawing this, that's -3. And the minimum would be, let's say, there. Okay, so it comes down like this. Sorry guys, down like this, through this, turns there, and up there, something like that. Not great, but it'll do. 1 minus 4. That's the quadratic. Now, the reciprocal function, which is 1 over this quadratic, well, it looks very different. Firstly, what's going to happen is it's going to have asymptotes at -1. X equals -1, vertical asymptotes, x equals -1, and x equals 3 here. Why is that? Well, because as x approaches -1 here, I'll write this as x approaches -1, y approaches infinity, because it's going to be x, this guy's approaching 0, 1 over a very small number becomes a very big number. Now, which infinity is it? Is it plus or minus? And I'll write here plus or minus infinity, because it depends which side we're on. Now remember, if this graph is positive here, this graph will be positive here. So what's going to happen over at this side is you're going to get a graph that does something like this, because as this guy approaches 0, he approaches infinity, and as he approaches infinity, or as x approaches negative infinity, this guy will just approach 0. Y will approach 0, because imagine if you put negative infinity, or if you prefer a big number like -1,000,000 in there, what happens is the denominator becomes very big, because -1,000,000 squared is like, well, it's a trillion. So it's 1 over a trillion and change, which is basically 0. Okay, so that's the left part of this. Then everything's just the reciprocal. So if this point is at -3, this point is at -1 over 3. So he is at -1 over 3. So that is 0, -1 over 3. And then if this point is at 1, -4, this point is at 1 over -4, or -1/4. So you just do 1 over, it's 1 over y essentially. So 1 over -3, 1 over -4, and hence here is 1 over 0, which gives me the asymptote. Okay, and then similarly to what I said here, as x approaches -1, and as x approaches 3, y approaches plus or minus infinity. Now in this case, because it's underneath the line here from -1 to 3, y is negative. So here 1 over y, or 1 over x squared minus 2x minus 3 is negative, so it has to be negative, approaching negative infinity, goes through that, and then down like that. Okay, and then finally the same thing is going to happen over here. It's positive because it's positive here. As it approaches 3, it approaches positive infinity, and as it approaches infinity, it approaches 0. So I'll write that as x approaches infinity, y approaches 0, for the same reason as over here. Sub in infinity there and you get 0. Now one final thing to note is, and guys, I probably should write x and y here. One thing to note, there is a horizontal asymptote, and he did say state or indicating any asymptotes with their equations. So we need the equation of this horizontal asymptote. You can write it as, well, just write it as y equals 0. Y equals 0. And even, just to be clear to the examiner, right? Horizontal asymptote. Okay, that's it. That's 11A.